Hey guys, I hope you're having at least semi-exciting break. I don't think it's been weird and some things get confusing, especially some of this chapter. Ends up being one of the most complicated chapters of this semester. So 7D tends to be kind of hard. But once again, if you understand the patterns, if you understand SOHCAHTOA, sine, cosine, and tangent, it should be very easy. So what I'm going to try to do today is go over the first part of this, which is the missing angles. So if you would like to go to your 7D notes, I have everything already plugged in with all the answers as well. And then that way we could try to figure this out. And I can tell you just directly how to kind of go about trying to solve these problems. Now, first things first is if you have a calculator, you guys should have your TI Nspire calculator. All you have to do is type in TI Nspire and it should pop up right here. Mine has a teacher version of it, but it should be something like that, right? So then you guys can start that off. Now, before we do anything, you have to be in a certain setting. So you have to kind of go to your settings here, then go to document settings. What you're looking for is this first one that says angle. You have to be in degree. If you're in radian or gradians, then it's going to give you a completely different answer every time. So it's going to be way off completely. Now, what you do is you select degree, then you go all the way down, and you can press down, 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 down to make default. Hit OK. And then you can go to new document and should be fine. Do you want to save? No. Let's just start a new one. All right. So then what we're going to first do is use our calculator to evaluate some of the following trig functions. So here we have sine of 70. Now, you might not have known, but like sine is typically on a lot of calculators. In fact, if you want to, you can go to like, I don't know, scientific calculator, and you'll actually find scientific calculators here that'll give you sine, cosine, tangent, etc. And if you need a more advanced one, you can just Google search for them as well. So that's how you can find them if your calculator is not really working. So then here, what you have to do is you have to go to trig. It's right here. See this trig button, trig, 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 and you'll see all the different trig functions. We got sine, cosine, tangent, and then three that you haven't really seen yet this year. You might see them next year, possibly, but that's cosecant, secant, and cotangent, and then all the inverse versions of them. So, but we're going to stick to sine, cosine, tangent. Now, if we look back here, it said find sine of 70 degrees. So we're going to put sine, and it pops it in with parentheses of 70 degrees. You don't have to put the little degree sign. You can just leave it like that and it should be fine. Sometimes you won't even have to close it up. But let's hit enter. Bam. So we got 0.93. So let's write that in. So we have 0.93, but there's a 9 there, so this actually becomes 94. And that's it. Let's try cosine one now. So this one is going to be trig. Go to cosine, and we're going to do cosine of 70 this time. Cosine of 70 is about 0.34. Look at that 2. The 2 rounds down, so we're just going to have 0.34. All right, now let's try tan of 70 degrees. So we're going to go to the trig button, go to tan, and then plug in 70. Notice I don't even have to close it up, but I will just to be kind of clear. There we go, 2.7. There's a 4 and another 7. That 7 rounds up, so the 4 becomes a 5. And there you go. That's how you can plug in your trig values. Now I want you guys to try to plug in the rest of these, and you can check your answers on the inked version. So next, we're going to have to kind of talk about the ratios. Now we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Here it says find the ratio of sine of b. Well, here's b, right? So that means we're looking from this spot here. Now, what we typically do is always label. Make sure to label everything. So then this 5 would be your opposite, and this 10 would be the hypotenuse. Did you notice that they didn't give us anything here? That's because we really don't need it. They gave us these two for sine, and sine only uses the opposite of hypotenuse, so we're fine. So then the sine of b is equal to the opposite divided by the hypotenuse. And if we plug those in, our opposite was right here, which is 5. Our hypotenuse was 10, which is right there. So we get 5/10, which can simplify to half. And just for kicks, we're going to turn this into a decimal, 0.5. You'll see why in just a moment. Because half is also 0.5. So now it also says, hey, then evaluate the sine of 30. Okay, let's take sine of 30 degrees in our calculator. All right, so that means we got to go here. Let's do trig sine 30, hit enter. Hey, look at that, we got 0.5. So do you notice how the ratios are actually the same here? It doesn't matter. Just as long as you have the same ratios, they mean the same things. And that's the whole part we want to show you here. Now, what we're going to do next is look at sine inverses, or any of these inverse. Now, what is an inverse? Well, you guys see this little -1 here? That's a power of -1. Anytime we have power of -1, another way to say that is the inverse of something, kind of like the flip. Like, think about what's the inverse of Superman? And you can say a lot of things. You could say Bizarro, who is like his double, his evil opposite. Or think about the Flash, who is the Flash's inverse? Reverse Flash. So it's like that. It's the inverse or the opposite in a way. So then how do we plug this in? Well, we're going to go to that same button, trig. And if you look here, here's sine inverse. So sine inverse, it tells us to plug in 1/2. So let's just do 1 divided by 2. And that's it. Just hit enter. Hey, we got 30. What this is going to do, though, it's going to give us angles. So this is going to be 30 degrees. So then that's it. Now, cosine is going to give us the cosine inverse of 1/2. Let's see what we get here. Trig cosine inverse of 1 divided by 2. Hit enter. We got 60 degrees. Wow, these are nice. These are nice, perfect whole numbers. There's an equal here for some reason. Get rid of it. But will this always happen? No. You will sometimes get decimals, and really, really not nice decimals. So let's try this tangent one. Tangent inverse of 1 divided by 2. Well, there we go. See? Decimals. So this would be 26.565. The 5 rounds up, turns this into a 57 degrees. And that's it. So what these do for us is the inverse helps us to find missing angles in triangles. So essentially, we're going to use these inverse to find missing angles every time. So let's look at another version of this. So here it says solve for the missing angle. Well, really quickly, I always want to give you guys a little bit of a step process, like step 1, right? Here's our missing triangle. It has a missing angle here, and you can either use theta, which is like that circle. If you don't like theta, you can also use an X here, or you can just leave it as a question mark, because that's where you're looking at. So step 1, you always want to label. Label your opposite, your adjacent, and your hypotenuse. Our opposite here would be this 51, so put OPP. This 55 would be your hypotenuse, so let's put hype. Now, notice that they didn't give us this part. We really don't need it at this point, because as long as we have 2 pieces, we're fine. So second part, the step 2, then would be to find what trig function you're using. Step 2, use trig, trigonometry. Well, which one uses opposite and hypotenuse? Well, if you forget, you can always write out SOHCAHTOA, right? So you're looking for the one with an O and an H. O and H would be sine. So this would be a sine function. So we're going to say sine, but we're trying to find a missing angle. So we're going to say sine inverse, right? And sine inverse is going to be the opposite over the hypotenuse. All right. So then step 3, plug it in. Well, we have our sine inverse. Our opposite here is 51. Our hypotenuse is 55. And that's it. So then the last step here is just to put in your calculator. Step 4, you just put in your calc. So let's plug this into the calculator. So we're going to go trigonometry, sine inverse, 51 divided by 55. Hit enter, bam. And that's the angle that we are missing there. So then we know that our x, we can use this color, it doesn't matter. X is going to be equal to 68.6 0, 1 degrees. If you don't like x, you can use theta. In fact, let's get fancy and let's say this is theta. How about that? We'll be consistent. Theta. That means I gotta change this one. We'll make this theta. Bam. Okay. So that's how we do that. Let's look at 2 more of these. I want you guys to try the ones on the right side. All right, first up first, here's our theta in this corner. Then we're going to label. Well, this side here is the adjacent. This one here is the hypotenuse. Then think to yourself, hey, which function uses adjacent and hypotenuse? Well, if you've been paying attention, that's going to be your cosine function. So we're going to say cosine, and we're trying to find a missing angle, so we're going to say cosine inverse. And cosine inverse is the adjacent over the hypotenuse. All right, so now let's plug this in. Now, if you think you're quick and you can just skip that step and do it right away, that's fine. I'm just writing everything out for everyone who needs it. What's our adjacent? Our adjacent was 52. Our hypotenuse was 56. And we're going to plug that in here. So let's do trig. Whoops, come on. There we go. Trig, we're going to do cosine inverse of 52 divided by 56. Hit enter. All right, so we got that. So our theta, our missing angle, is going to be 21.78. There's a 6, so the 6 rounds up, turns that 8 into a 9 degrees. And that's the measurement of that angle. Last example before we stop this. Okay? All right. Once again, here's our missing angle. Let's put theta there. Then label everything. This is your opposite side. This is your adjacent side. So then, which function uses opposite and adjacent? Well, if you've been paying attention, it's going to be tangent. But we're trying to find missing angle, so it's tangent inverse. So what's tan inverse? Well, it's going to be the opposite divided by the adjacent. So we're going to take tan inverse of the opposite, which is 29, divided by the adjacent, which is 38, and plug that in, and then we're going to get our theta. Our theta will be, all right, trig tan inverse 29 divided by 38. There we go. So then we have 37.3. That's a 4. The 9 rounds up, so it'll be 35 degrees. And that is it. So this is how we find missing angles in triangles. What we need is always to have 2 sides. If we have all 3 sides, we can definitely find it too. But you need at least 2 sides. With 3 sides, you're basically allowed to find any angle you want. So for instance, in a more abstract way, if you want to look at it, I'll add just a quick little thing here. Let's just hit. For instance, if you're given a triangle like this, and let's say this is a 3, 4, 5 triangle, right? Well, you can use an angle, and to find this angle here, you can use any of the 3 trigonometric ratios. You could use sine, cosine, or tangent to find this angle, and you would get the same thing no matter what. So, for instance, if you wanted to find, hey, let's look at the angle here. Let's try to find our theta. Let's use sine inverse. Well, what's your sine? That would be the opposite and the hypotenuse. So that would be 4 over 5. If you wanted to use cosine here, we'd have to use the adjacent over the hypotenuse. So that'd be cosine inverse of 3/5. And if you want to use tangent inverse here, then you could use the opposite or the adjacent, so that'd be 4 over 3. Now, these should all give us the same exact thing if we did everything right. So we'll do trig sine inverse of 4 divided by 5. And we get what? 53.13. If we do, let's see, trigonometry cosine inverse of 3 divided by 5, we get the same exact thing, 53.13. So then if we try tan inverse of 4 divided by 3, we get the same thing, 53.13. Now, that just shows that you can use any trigonometric function to find your missing angle, but you have to have the right sides for it.